10.4 Infinite Geometric Series. The objectives. In the last lesson, you learned about finding the nth term of a geometric sequence. You learned about finding the sum of a geometric series. And specifically, this is the formula for finding the sum of a finite geometric series. Finite meaning the series will end. But what if you wanted to find the sum of an infinite geometric series? Well, there's a formula for it. And the formula is this. There is one catch though. The ratio, or the absolute value of the ratio, must be less than 1. Because if it's not, then it's not even possible to find the formula, it's not possible to find the sum of the infinite series. Okay, so we're going to find the sum of this infinite series if it exists. To find out if it exists, we need to find the ratio. The ratio you can find by taking, say, the second term, which is negative 3 halves, and dividing it by the first term. Negative 3 halves divided by 3 is negative 1 half. You can check that using your calculator. So the formula for the sum of an infinite series, notice there's going to be no subscript on the capital S here. So it was the first term over 1 minus the ratio. The first term is 3. The ratio is negative a half. So I'm doing 1 minus negative 1 half. So that's actually 3 over 1 plus 1 half, which is the same thing as I'm going to go over here. I'm going to call that 3 over 3 halves. Because 1 plus a half is 3 halves, which is the same thing as 3 times 2/3, because dividing by a fraction is the same as multiplying by a ratio, and that's the same thing. 3 times 2/3 is 2. So the sum of the infinite geometric series shown above is 2. Let's find the sum of this infinite geometric series if it exists. To find out if it exists, we need to check the ratio. Ratio must be less than 1. So for this ratio, we can again take the second term, which is 4, divided by the first term. 4 divided by negative 4/3, which is negative 3. Oh, fail. The infinite sum does not exist. Does not exist. By the way, this is sometimes abbreviated DNE, because the absolute value of the ratio must be less than 1. And negative 3, the absolute value of negative 3 is not less than 1. So it's like a less than sign with a slash through it. Here's your first video quiz question. And your second video quiz question. All right, the next item on the agenda is to talk about sigma notation. Here we have this gigantic E looking thing, which is the capital Greek letter sigma. We have some business underneath it, we have some business above it, we have some business to the right of it. The business to the right of it, in this case f of k, this is basically the formula for the terms of a particular series. The business below it is telling you where you will begin in the series. So here you are going to begin when k is equal to 1. And then the value above this giant sigma is the last value of k. I know that probably none of this makes any sense to you. It'll start to make sense when we do an example. Here's an example. So in this problem, we are starting with k is equal to 2. We're going to end when k is equal to 5. We are going to progress through all of the integer values from 2 to 5. And the formula we're going to plug those values into is the 4k plus 2. So here we go. When k is equal to 2, we're going to have 4 times 2 plus 2. Then we're going to go through the integers. When k is equal to 3, we're going to have 4 times 3 plus 2. When k is equal to 4, we will have 4 times 4 plus 2. And when k is equal to 5, we're going to have 4 times 5 plus 2. We stop here with 5 because the top number above the sigma is 5. And sigma means sum. It means add them all up. So we're going to calculate these values and add them all up. So here I have, this is 8 plus 2, so that's 10. This is going to be 12 plus 2, so that's 14. This is going to be 16 plus 2, so that's 18. And this one's going to be 20 plus 2, so that's 22. 10 plus 14 plus 18 plus 22 is 64. And that's it. The value of this expression is 64. Let's do another one. We're going to plug in when k is equal to 4, when k is equal to 5, when k is equal to 6, when k is equal to 7, and when k is equal to 8. So we're going to have 3 plus 4 squared plus 3 plus 5 squared plus 3 plus 6 squared plus 3 plus 7 squared plus 3 plus 8 squared. I went ahead and wrote down the values of all of those expressions, 19, 28, 39, 52, 67. When you add all those up, you will get 205. So the value of this sigma expression is 205. Here's your third video quiz question. Let's do another one. We start with k is equal to 1, and they want us to stop when k is equal to infinity. Well, I can't do that because I can never get to infinity. There must be another way. Well, let's write down the first few terms. So when k is equal to 1, I'm going to have 5 times 1/2 to the 1 minus 1, which is going to be 5 times 1/2 to the 0, which is just going to be 5. When k is equal to 2, I'm going to have 5 times 1/2 to the 2 minus 1, which will be 5 times 1/2 to the first, which is 5/2. Let's do one more. When k is equal to 3, I'm going to have 5 times 1/2 to the 3 minus 1, which is 5 times 1/2 squared, which is going to be, that's going to be 1/4, so 5/4. Now, the reason that I went through all of that is so that you can hopefully see that this is the beginning of an infinite geometric series where the ratio is 1/2. And since we're going to infinity and the ratio is less than 1, I can use the formula for the sum of an infinite geometric series. All I need to know is the first term in the ratio, so that's why I wrote down the first couple of terms. The first term is 5, the ratio is 1/2. So we do 5 over 1 minus 1/2, which is 10. So the value of this sigma expression is 10. You might be getting a little bit tired of doing all of these sigma problems, but we have one more to do, and I do have a point to make, which is this. It might be a little bit too tedious for us to actually write down the value of when n equals 1, when n equals 2, and so on. So we could write down the first few terms and check to see if I have an arithmetic or a geometric series, and then I can use one of those formulas. Let's write down the first few terms. So when n is equal to 1, we're going to have 3 times 2 to the 1 minus 1, which is 0, so it's going to be 3. When n is equal to 2, I'm going to have 3 times 2 to the 2 minus 1, which is going to be 3 times 2, let's just go ahead and write down, 3 times 2, which is going to be 6. And then when n is equal to 3, we're going to have 3 times 2 to the 3 minus 1, which is going to be 3 times 2 squared, that's going to be 4 times 3, which is 12. Okay, so here again I see that this is geometric, that the ratio is 2, that the first term is 3. Well, wouldn't you know it, up here the number in the front is 3, the number that's the base of the exponential part of it is 2. And in order for me to find that sum, I can simply do this formula, S sub n equals A1 times r to the n minus 1 over r minus 1. So the first term is 3. R is 2. We're finding the sum of the first 12 terms, minus 1 over 2 minus 1. And when you calculate that, you're going to get 12,285. So the value of that sigma expression up there is 12,285. And your fourth video quiz question.